Example 2 here is expanding logarithms. So we're just going to work backwards. Take each thing that we have and split it into one individual piece. So each factor becomes one individual term. Here we have a 4, an x, and a y. So when we multiply, which is what's happening in our numerator, and divide, we do different things. When we multiply, we add our logarithms. When we divide, we subtract. So, big thing here is to remember to keep that same base. Our base here, remember, when there isn't one, is 10. We don't have to write it. It's kind of like log base 10 of x. You can write that if you want to, but it's kind of like saying x to the first power, or the square root of x with the 2 there. We don't need those. You can, but you definitely don't need them. We know just by looking at it, if there isn't anything there, it's log base 10. So, we have this 4 is where we're going to start off with. From the 4, we're multiplying by the x. And when we split these and expand them into individual logarithms, we split multiplication by adding log base 10 of x. We split division by subtraction. So we're going to subtract log base 10 of y. And this right here is our expanded logarithm. Part B here, same idea. We have one thing in the numerator, one thing in the denominator. We're going to take log. Here we have base 9, x to the 4th, and since we're dividing, we're going to subtract log base 9 of 729. We've got to do some simplifying here. This exponent we swing to the front as our product property. We can do the same idea here with the 729. 729, if we break it down, is 9 times 9 times 9. Okay, it's 9 cubed. We also could have broken it down into 3s and simplified. I stopped at the 9s because my base is a 9, and that's going to be helpful here in just a second. So when we rewrite this, I'm going to have 4 times log base 9 of x. Remember, we never want to leave any exponents. If we can, we want to swing them forward as multiplication. Here, I'm going to have log base 9 of 9 cubed. 729 is 9 cubed. We can take our our exponent, swing it to the beginning. So right now, I'm going to have 4 times log base 9 of x minus 3 times log base 9 of 9. And our final step here is to remember that log base b of b is 1. So we're going to have 4 times log base 9 of x minus 3 times 1, which is just 3. So that is our expanded version. Now, go ahead and pause to try these if you'd like. I'm going to get started. Same idea here. We have log base 3, but let's split up our 250 right away. 250, let's see if there's any exponents or anything we can split this up. We want it to always be prime numbers or close to prime if we can. Nothing that has exponents. So 250 is 2 times 125. 125 is 25 times 5, and 25 is 5 times 5. So right now we have 2 times 5 cubed. And we have an exponent, which means we're going to have that as its own term here. It's going to start off as a factor and then end up as its own logarithmic term so that we can simplify it. So right now, instead of 250, we have 2 times 5 cubed. Start off with log base 3 of 2. Multiplication means we're going to add the second logarithm when we expand. Log base 3 of 5 cubed. Then, when we divide right here, we subtract log base 3 of 37. Final step is to take that exponent and swing it to the front. Log base 3 of 2 plus 3 times log base 3 of 5, and again that's using our product property of logarithms, minus log base 3 of 37. And that is as expanded as we can get. Again, our goal is to get these to be as simple as we possibly can. B here, same idea. Log base 3, 9 we can write as 3 times 3 or 3 squared. So I'm going to rewrite this as log base 3 of 3 squared times x to the 5th. Again, we split up logarithms when there's multiplication into individual terms by adding. So the first one's going to be 3 squared. When we split to individual logarithms, we add when there was multiplication. Log base 3 x to the 5th power. Take our exponent, swing it out front, same thing with our 5. Right now we have 2 times log base 3 of 3 is just going to be 1. 5 log base 3 of x. So we have 2 plus 5 times log base 3 of x is as expanded as we can go there. Take note, change a base on page 464. To evaluate a logarithm on a calculator, we use the change of base formula, which is log base b of m equals log base c of m over log base c of b. All that means, guys, is that we have to have the same exponent here, or base here. That 3c has to match that c. It does not matter which ones we use. Our calculators come equipped with log and ln keys. Log is log base 10. ln is log base e. It's called our natural log. It does not matter which one you use. Either way, you will get the right answer as long as you use the same one for both. I'm going to use the log key here, but it does not matter. Again, you could use the ln if that's what you really want to do. So the idea here is that we take log of 27 divided by log of our base 81. And we just type that right in our calculator. We're going to get an approximation. So big thing here is to make sure when you type this in log of 27, you've got to close that parenthesis right there. Divided by log of 81. And I got 0.75. Or you could write this as 3 over 4. Same idea. On B, we take log of 36 divided by log of our base 5. And if you're worried about remembering which one goes on top and which one goes on bottom, I always remember that our base goes on the bottom because it's already kind of dropped. It's already lower. So that's how I remember that that's the lower part of our fraction. Okay, because the 5 is already dropped, that's what we drop to the denominator. When I type this in, log 36, don't forget to close that parenthesis, divided by log of 5, we get about 2.226565505 or 2.23, depending on where you round to. Go ahead and try these. I'm going to go ahead. So in in A here, we have log of 32. Remember that number's already kind of up, higher than the 8, so we keep it in the numerator. The 8 has already dropped, so I'm going to go ahead and put that in the denominator. Log of 32 divided by log of 8 is going to give me, not approximately, it's going to give me exactly 1.66666. So that's going to be 1 2/3 or 5/3. Same idea here for B. We take log of 18 divided by log of 4. And again, this is called our change of base. It changes our base number to one that we can use with our calculators, 10 and 10. We could pick anything. We could change it to be log base 401 of 18 divided by log base 401 of 4, but that's not very helpful because the only ones that our calculators come equipped with are 10 and E. So when I type log 18 divided by log 4 in my calculator, I get approximately 2.085, depending on where you round to. 2.084962, so I'm going to go 0.85.